22 teams participated in the Waterborne Trial Visions Competition 2014. In particular, the following ideas were submitted. Ensan, a semi-submergible liner. Universität Antwerpen, Maritime World Cities. Coventry University, a mothership for accessing the far shore wind farms. A mothership for accessing the far shore wind farms. Offshore wind farm mothership. WFSV project. Sustainable transatlantic travel. Trimaran high-speed cruise logistics ferry. Universities of Glasgow and Strathclyde, floating power generation plant. University of Liège, subsea Arctic oil platform. Ice-breaking semi-submersible vessel. Chalmers University of Technology, the potential role of urban waterways in sustainable urban freight transport. Shortlisted contributions. KTH Royal Institute of Technology, Shubanan, the water train, ICAM, using a vertical access wind turbine for better energy utilization of cargo ships. Chalmers University of Technology. Field Development Floater, Coventry University. Trimaran high-speed cruise logistics ferry, University of Newcastle upon Tyne. Wind farm operation and maintenance vessel, Universities of Glasgow and Strathclyde. Deep V catamaran cruise ship, University of Applied Sciences Bremen. Small crew tender vessel for offshore wind parks. Winner contributions. University of Newcastle upon Tyne, an electric transport design for Suez Canal. University of Liège, robust design optimization for operational profiles. University of Applied Sciences Bremen, green offshore crew tender concept. Waterborne, first place green offshore crew tender concept. With the increase of installed power offshore from European coastlines also comes an increase in the demand for maintenance of the wind turbines. The green offshore crew tender concept therefore describes how the transport of the maintenance crew can be performed as safely as possible. Special emphasis was put on a design that performs perfectly in the rough working conditions of the North Sea while dealing as little damage to the environment as possible. The design features a hull optimized for minimum wave resistance and favorable seakeeping characteristics in adverse conditions due to the variable draft. This was achieved by combining the seakeeping abilities of a swathe hull with the speed advantages of a catamaran for a unique underwater hull. The proposed LNG electric hybrid propulsion system and additional solar power generation support the green idea and provide the option of emission-free operation within the wind farms. To protect the maritime wildlife, this offers a considerable potential for the reduction of noise pollution. Waterborne, second place, robust design optimization for operational profile. Lots of effort has been put into the development of environmental friendly devices and technologies to reduce ship emissions. Unfortunately, the traditional way of designing a ship only considers one defined mode of operation. As this is far from reality, a design that performs optimally in various conditions therefore can lower the overall emissions even more. Various methods were looked at to achieve a more robust design for a RoPax ferry. Amongst the multi-objective optimization and the weighted different objective optimization, the single objective optimization with constraints proved to be the most rewarding. By running the optimization process, a maximum improvement of the wave resistance of 8.31% was reached. After viscous effects were introduced, a total resistance reduction of a maximum of 2.84% was achieved. Overall, the study proved that there is a fuel-saving potential that can be used even for well-designed ships if the design is set up more robustly. Waterborne, third place, an electric transport designed for Suez Canal. About 70% of ship emissions occur within 400 kilometers of coastlines, causing sulfur emissions, particulate matter, and other various environmental problems in air quality through the formation of ground-level ozone. When passing through the Suez Canal, the slow-speed diesel engines have been proven to produce higher NOx, SO2 and other harmful greenhouse gases due to the increased combustion residence time in high-pressure values which are related to slow speed limits of the canals. This can be avoided by towing the vessels via all-electric tugboats powered from shore through a high-voltage power cable. Specially designed locomotive vehicles running alongside the canal will transmit the required power through the festoon cabling system to the tugboats. The power supply is possible with solar collector farms so that the implementation of this system would not only improve the air quality in the area of concern, but would also bring along many socio-economic benefits for the entire Suez region.